Ja, mein Name ist Reinhard Koll.
My name is Reinhard Koll, and I've been with WFL from the very beginning, since 1993. Before that, I started as a technologist at Voestalpine. I was a machining technician at the time, and then switched to WFL's project planning department. That's the area where we deal with customer inquiries and elaborations for customers. In other words, the department where everything is technically implemented once a machine has been sold. That's how I gained my experience. Here at the company, I have been involved in complete machining since 1985 and am now responsible for application technology.
So, the topic of complete machining has been around since 1985.
The topic of complete machining was already present back then. It failed at the very beginning because of the tool systems. There were only systems for turning or milling, but no system for turning and milling together. That's why the first MILturns, which were already called MILturns back then, were equipped with a turret with turning tools and a drilling and milling unit with 40 tools. And when these tool systems came onto the market, which could turn and mill, it was also possible to combine this mechanically and in terms of mechanical engineering, and to create a single tool carrier that could accommodate all the tools.
When has the milling spindle been added?
The milling spindle already existed in the very first MILturn, but only for rotary machining and not for turning operations.
What does WFL mean to you as you have been with the company for so long?
Definitely family, lots of acquaintances, lots of friends. But what I always find so interesting about the job is the constant development. There's always something happening, whether in the tool sector or in the materials sector. There are new requirements. Customers come with new problem parts and ask, how can I manufacture this? And then it is our task and also our goal to offer solutions, either to develop new technologies or to implement existing ones in the MILturn.
Is there such a thing as a typical WFL customer?
There's no such thing as a typical customer. That's difficult. We have relatively small companies, contract manufacturers who simply need machines on which they can work flexibly. Today they get an order for a shaft part, tomorrow an order for a chuck part, the day after tomorrow they might be asked to produce a crankshaft as a tip cover. In other words, there are companies that are simply looking for very flexible production equipment, but there are very specialized companies that buy the machine precisely for one production area, one workpiece group.
What technologies does a MILturn combine?
The name MILturn basically comes from mill, milling, and from turn, turning. The two terms are always included, as is drilling, so turning, milling, and drilling are always on board. I would say that 70 to 80% of applications involve gear cutting technology, that is gear hobbing, shaping, skiving, or whatever else is possible. What is always on board is the measuring probe. We are always working in a production area where very tight tolerances have to be adhered to. It is therefore important to measure during the process and not find out at the end that you have produced rejects. When we manufacture, we want to constantly monitor it, correct it automatically if necessary, and produce good parts. This is also important because many of our customers produce very small batches or even individual items. This means that there is perhaps only one fudge part, and this one fudge part has to be turned into a good part in the end. There is no room for errors or rejects.
Does that mean that the machine also bears a lot of responsibility?
Yes, exactly. And that's why we try to integrate as much functionality as possible into the machine in order to relieve the operator of responsibility. Until now, many things had to be done manually. A typical case: you want to spindle a very precise hole and the tool wears out at some point. This means that the operator then has to readjust the spindle tool, which is of course a source of error. This can lead to rejects being produced. We are now also showing a spindle tool from Big Kaiser that is able to adjust the diameter itself. So we spindle a hole, measure the hole fully automatically in the machine, tell the spindle tool to spindle 13 micrometers larger, which then adjusts the diameter. It finishes spindling, then we take another control measurement, and that's it. This ensures that these processes, which are prone to errors, are automated as far as possible.
Diese Vorgänge, die fehleranfällig sind, möglichst automatisiert werden.
You also work closely with partners. How important is that for WFL?
I think a lot of things would not be possible without partners. That has to be said quite clearly. We have a lot of expertise in application technology and machining. But we are not clamping device manufacturers. We are not tool makers in the traditional sense. We need partners who do this for us. Of course, it is always mutual inspiration. We also come up with ideas where some people say difficult. We haven't done that yet, but then we try to solve it together. Partners are very, very important to us.
Workpiece materials are becoming increasingly sophisticated. What kind of different materials can be processed with a MILturn?
Yes, basically all of our machines are suitable for all types of workpiece materials, whether it's steel, aluminum, or a heat-resistant titanium alloy. We can machine these materials on all our machines in terms of the machine design, drive power, and rigidity. Of course, there are always challenges where you say, okay, I can machine it, but the performance just isn't right yet. And then a close cooperation with the tool manufacturers is also necessary in order to find tools that offer the corresponding tool life, but also the economic efficiency to be able to machine effectively.
So WFL supplies the entire production process.
That is usually the case. I would say that almost every first-time customer buys a turnkey solution from us. We work out the complete technology, we prepare machining time calculations in advance, look at the tolerances to see if they are feasible. When the customer then buys the machine, we create the tool design. This means they can see exactly which tools will be used. We create the NC program and then manufacture the component here in Linz. The customer comes for a preliminary acceptance test, accepts the machine and the component, checks whether the quality and machining time are right. If everything is right, the machine is released for delivery. The same acceptance test is then usually carried out again at the customer's premises to see whether the machine has survived transportation and reinstallation. And finally, there is an operator training at the customer's premises, where the staff gets trained on the machine.
What are the typical industries that WFL serves?
Fortunately, we are broadly positioned in terms of industries, which has often helped us in the past. So we are not just home in the traditional automotive industry, we are strongly represented in the aviation industry, especially in the area of engines, engine shafts, engine discs, and in the chassis area. We're also strong in the oil field business since a long time. They are using super complex work pieces, very challenging for the process for the tools. However, there is less business there now. In the area of crankshafts, we are clearly busier again and are experiencing higher demand, including in the area of power generation, which includes a wide variety of forms such as wind energy, wave energy, water energy, steam turbines, and generator shafts.
Is there a component with a particular challenge that has already been worked on?
That would go beyond the scope of this article. But I can remember one part. That was the impression cylinder. These were previously manufactured in incredibly complex processes in various steps. One of the process steps was the grinding of an inlet edge. The cylinder is basically round but has an inlet radius towards the channel so that the paper does not tear off there when it is accelerated. This was an incredibly time-consuming grinding process, which we simply replaced with a turn mill process. We milled the jacket, and this milling of the in-feed radius was simply a waste product that didn't even cost any more time. That was a huge step for the machine industry at that time, because it really simplified the process dramatically.
How big is your department? How many technologists work at WFL?
Application technology consists of two areas. One is project planning, which is active in the pre-sales phase, and the other is the technology group, which then implements the order. The group consists of around 50 people in total, which is about 10% of the entire WFL workforce.
Is the WFL team also on site at the customer's premises?
In the pre-sales phase, there are of course consultations with customers at our premises or at trade fairs. Sometimes there are also demonstrations or tests. That is when the customer says, I can't imagine it, I can't believe it, or it's so borderline that we prefer to try it out first to see if it's really possible. Then we also carry out tests in-house. And the second group, the technologists, are of course usually with the customer for longer because they carry out the acceptance tests on site, provide training, and very often also provide support during production. We also offer to support the customer for a certain period of time once the machine has been delivered delivered. Of course, there are often certain reservations when a large number of technologies that were previously split up are suddenly combined in one machine. It is then a very good support for our customers if the specialists remain on site for a longer period of time.
Is the topic of complete machining actually limited?
Yes, if we look at the topic of grinding, we also integrated grinding a few years ago. We can therefore equip machines with grinding functionality. However, it must be clearly stated that we do not want to replace the classic grinding machine. Grinding makes sense for me where we say we have 90 to 95% of the machining in the MILturn anyway. That is milling, MILturning, drilling, deep hole drilling, and more. And I might have to place the workpiece in 2 ground bearings and put it in a grinding machine somewhere. The reclamping alone takes longer than if we finish grinding it in the MILturn. And that's where I say, okay, if the grinding part doesn't exceed a certain amount, it makes sense for us. If it's a shaft with 20 diameters that all have to be ground, I would still do it in the grinding machine.
Are there any manufacturing processes that are not practical or possible?
We are always learning. There are always new processes due to customer requirements, where customers also say, yes, how can I do that? Whether it's honing, grinding, roller burnishing, whatever different processes are available on the market, we try to integrate them if it makes sense for the customer.
Honing means maximum precision on the component. What is feasible with MILturn machine?
That's difficult to answer in general terms, but if it has to be very precise, I would say that we are already in the 10 micrometers range or just below.
At the technology meeting, WFL is demonstrating a quick change system on an M80. Since when has this been in use?
This quick change system is new. It is being presented for the first time at the technology meeting. The background is that many customers want to machine aerospace components such as discs, rings, and housings horizontally because then they don't have a problem of them running full of cooling lubricant and the chips remaining in place, as is the case with vertical machining. Horizontal machining has many advantages when cutting. However, the component is loaded onto the fixture pallet outside the machine, as some of these workpieces are so thin-walled that they can no longer be clamped in jaw chucks. And this happens outside the machine. Otherwise, you would spend ages setting up in the machine. And this quick change system enables us to clamp the component externally, align it, screw it down, and then load the finished pallet into the machine either via the crane or via feeder solution, as exhibited here, or via an automated loading system. This means I have a very fast and super precise workpiece changeover and can carry out the entire setup process outside the machine.
Does this ultimately mean that reducing non-productive time is very important for customers?
Absolutely. The machine is only good when the doors are closed and the program is running. Whenever the doors are open, something is actually wrong.
How important is automation for WFL customers already?
I would say very important in the small to medium range. If you think of the 150 series with a weight of 20 to 25 tons, automation is not an issue. But especially in the smaller range, it is very often the case that the processes in the machine and the machining processes are already super optimized, so there is little room for improvement. But then you see that the machine is perhaps running on the third shift or over the weekend. And that's actually where the great potential lies, that you can still use the machine if you load it automatically. That's why we're also showing an automatic jaw change on the MILturn M35. This means that the machine is also able to retool itself. Very often our customers don't run huge batches, but 5, 10, 20 parts, and then the machine is perhaps finished with a first batch by Saturday afternoon. Then it would stand still again until Monday morning. This way, however, the machine can retool itself with this jaw change and start the second batch automatically without an operator being present.
If someone is interested in a MILturn from WFL, how should the process be started?
We always start with workpiece drawings. That's what everything is based on. We need to know how big the parts are, how heavy, what are the necessary technologies, what are the tolerances, what does the blank look like, and then we configure a machine around these requirements. In other words, machine type, machine length, what options we need, what coolant equipment. We design everything that is so variably configurable around this request.
diese Anfrage herum.
Finally, if we look into the future, where do you see WFL in 10 to 15 years' time?
Ja, ich denke,
I think a lot will still be happening. I am quite confident about that. A lot will happen in terms of both materials and tools, and we will certainly implement other processes that we are not even thinking about today. As has already happened, if I think back to 15 years ago, we are doing things today that we didn't even think about 15 years ago. There's a lot more to come, and I'm already looking forward to it.
Ich freue mich auch schon drauf.